So now in this video, we're going to switch a couple of, somewhat higher wattage LEDs right there. This switch isn't in the best spot. It's not making the greatest connections, but it's doing okay right there. So, alright, so we got it turned on, and me pressing the switch isn't turning it on directly. Instead, I could wire it up, but we're going to demonstrate a somewhat higher wattage bipolar junction transistor. So this is a PNP bipolar junction transistor. Previous video, we used the NPN bipolar junction transistor for basically the exact same circuit, except for we were switching from the positive supply instead of the negative, because PNP is the opposite chemistry of NPN. And I'm not sure of the wattage of the transistor, but there you can see the transistor. This is the TO220 package. This is the TO92 package right there. So normally for switching an NPN bipolar junction transistor, you'd be using like the 2N3904, but that shouldn't even be used to switch one of these LED modules. And then there's the 2N2907, and it can switch up to about 600 milliamps of current. It's the PNP version of the 2N2222. So it may be okay for switching these, you'd wire it the same, but it's still kind of pushing it. 400 milliamps of current, I think, is like 2/3 of its maximum. But yeah, for brief periods of times, it's probably okay, and maybe okay, like all the time. But still, this is probably a good circuit now to use a beefier transistor. These, we'll zoom in, we'll take a look. So yeah, this orange jumper from the positive supply, it's going to the other orange jumper to the positive supply, and then it's going to the emitter, as you can see there, right pin, but now we turned it to the top. Middle pin is a collector, bottom pin is the base. So the red jumpers here are going to the collector of the transistor there, middle pin. This is also the collector, the tab right there. Be aware of that. We don't have a heatsink or anything, and if the heatsink's conductive, then it's going to also be part of the collector. So don't let that touch anything that could touch the collector that you don't want to. And then, of course, we have the base down there. And I kind of saw the glow there. I can give it a stray signal enough, of course, even these brighter LEDs. So we have the switch there. Now it's going to the negative supply when we press it. That's given a connection to the base from the negative supply when I press that 330 ohm resistor for a couple reasons. One thing is we're switching quite a bit of current. So the more current you're switching, even if the gain is the same, you need some more base current. Here we got emitter to base right there. That's one thing. Also, these transistors that are higher wattage can, switch more current and stuff. They tend to not have as high of a gain as the smaller transistor. So it's not always the case, but that's commonly the case. So if the transistor has a gain of 50, let's just say we have 400 milliamps of current there. Maybe we might want to design this to be able to handle 500 milliamps of current. So you'd want at least 10 milliamps of current flowing emitter to base in order to be able to switch 500 milliamps of current. Now it's actually about 400, but still, you want to over design things. And a heatsink is optional. Don't think I mentioned that yet. And I didn't add it. You didn't see it. There would be a big thing attached to it. And I put that away. But I had another transistor in the last video, the NPN version of the circuit. I left the heatsink on there. But one reason why I didn't put this note on that schematic right there. So I wanted to make sure to show the heatsink because it was on there. But yeah, we're using the TIP32C. And that's really about it. We have a maximum current. I think this is definitely with a proper heatsink. And again, I don't find like a lot of info on what the proper heat sinks are. I kind of put the heat sink on there and then look at with the thermal camera how hot it's getting. And so, it creates heat, but if it dissipates heat out, then it's not going to get as hot. If it's not being able to dissipate heat fast enough, then it gets hotter. You can see that with the thermal camera. Hopefully that makes sense. But yeah, you can put up to a 1 amp of current through the base right there. So that's another thing indicating to me that you kind of need, a little more base current than you would for a transistor that's probably has a higher gain, but I don't know for sure. So here is the LED module I was lighting, one of the two. So they were parallel, so you'd have twice as much current as if you were just lighting in one of them. And if you wanted to wire them in series, then you would need 10 volts to light them, and then 200 milliamps, I mean, of current would flow through them. But we're not going to worry about that. But yeah, these they just have pads there. I had to solder the wires on, and I got this one's not too bad, but I got more solder than I wanted because the iron was rusty. So I got new soldering tips, and I might make updated videos on this. But yeah, that's it. It's got a resistor already built on there, and this is a heat sink right there. And I'm not sure what it's connected to electrically, but it's probably conductive. Probably don't want to touch anything else conductive that you don't want. But in any case, we used the NPN last video. Now we got the PNP version. I got them out of this kit. The heat sinks that I use in my videos I bought separately right there. But I think one of my semiconductor kits includes like 2 or 3 heat sinks or something. This one I do not believe did. I believe I'm just using ones that I bought independently, but they look the same. So yeah, that's NPN version, PNP version, and you can tell it's PNP because it shows negative voltage. So you can wire up the exact same circuit for the most part, but current flows in opposite direction, as does voltage. So that's why you just have, this would be a positive voltage even though there's no plus there, and a positive current. Whereas this one's a negative because currents and voltages are going in opposite direction. But the pin layout is not opposite. If you're looking at the front of the two of them, the base is to the left, collector is in the middle, and emitter is to the right on both of them. And depending on how you turn it, either the base or the emitter would be top to bottom. But the main thing is, the emitter from this one goes to the negative supply because it's NPN, and the emitter of that one goes to the positive supply because it's PNP. So now that was a pretty simple circuit, so I explained a little bit more. I believe in getting semiconductor kits like this after you get your basic components. So these would not normally be, probably any of them, in a basic kit. But we already saw there's transistors, there's a MOSFET even, but it's only N-channel, Darlington pair and stuff. And there's voltage regulators right there, adjustable voltage regulators. This one, one reason why I bought this, it has the L version of the voltage regulator. So the L7812 right there is TO220 package for higher power demands, and the 78L12 is the same component, except for it can't handle as much power, of course. But yeah, it looks like voltage is the same. But instead of 1 amp of current that you can use, and I'm not sure if that's with or without the heatsink, but in any case, instead of 1 amp, you got about 100 milliamps right there. And yeah, it doesn't look like the pin layout is the same either. So whenever you're using any component that is like multi-pin, make sure you check the data sheet and look up the pin layout. You know, they get confusing. There's not like a system you can memorize or something. You know, if you use them long enough, you'll start remembering like what a bunch of their pin layouts are. But even then, you might misremember or something. I've done that before, so that's my suggestion. But in any case, went on long enough. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.